I'm here for another software thing. It's going to take me a minute to explain, but here's the catch. Amazon, trillion-dollar company. What built their trillion-dollar company? It's not book sales. It's their API, the services they offer. Their software is sort of magic, and it's amazing. But the software that built their industry, that built their company, it's also going to take it down eventually. We'll talk about how. It's happening now. You can see it. And if you work in the industry and with cloud providers, hybrid cloud, multi-cloud, infrastructure as code, we're going to touch on all that and probably get you thinking. Let's dive in. Let's suppose I've got the world's most simple application, a blog. It could be WordPress, could be Drupal, could be anything. Just something that requires a little bit of interaction. Yes, I know the new hotness is something like Hugo, but let's just assume, for the sake of the argument, it's something like this. There's a database component, which has its own storage, a PHP component, or just some compute component if you prefer, somewhere code is running. Yeah, it could be Node.js, it could be PHP, it could be Python, whatever. And then we have storage, because we need persistent storage, right? When we blow this away, we don't want to lose all our hard-earned blog content, or our, blood, sweat, and tears that went into our blog content. And then we've got some kind of a connection to the internet, probably a domain name. And there's a lot of infrastructure around handling this if you want to do it correctly, like your SSL certificate. Maybe you want a load balancer. You can have multiple front ends. We'll talk about that in a little bit more complexity, but basically I've got some stuff that I want to store permanently, and then some computation that needs to be done, and then I also need to store some data. So in Amazon, I could do this with an EC2 instance. And the database part, you could run a database on another EC2 instance, but that would be dumb and it's not very fast. Amazon offers a different service for that. Same with like the internet. Like you could run a public IP address on your EC2 instance, but that would be dumb. Amazon has different services for that are specialized. You can do Route 53 for DNS, and there's a different little service for every piece of this. Storage, I could use an elastic file system, and then I could make this an autoscaler, or I could use S3 for this, whatever. This is going to store all my uploaded images and configuration data, and maybe even some of the PHP. Although, if I'm not really customizing the blog platform, like if I'm not customizing WordPress a lot, I don't even really need to store that. And so how you stand up this infrastructure? Well, you could do it manually. You could provision EC2, log into it as root, install your packages, blah, blah, blah. That's not really how we do it anymore. We do it with infrastructure as code. Infrastructure as code is sort of becoming the new hotness. So if you have the Amazon AWS CLI, there are recipes out there that you can download and run it, and it'll go in your Amazon cloud and it'll provision all this stuff, and then it'll be created and ready for you to just log into WordPress or log into Drupal and finish the configuration through the GUI. You can also do that through the command line. Like those platforms offer command line tools for automating that, because that's where we are these days. But suffice it to say, this is our widget. It is very simple, but there is permanent storage and a whole bunch of other stuff to that. Allow me to introduce Terraform from HashiCorp. Terraform is, an answer to a multi-cloud solution. And what it does right now today is make it so that you're not dependent on the Amazon AWS CLI to do that kind of provisioning. You can define it in an abstract way, the way that Terraform dictates. And then it can speak Amazon AWS, but it can also speak Azure. So if you want to deploy this in the Microsoft cloud, you don't really have to change anything in your, Terraform configuration files. You just tell it, hey, let's deploy this in Azure. You can also deploy this in Google Compute. You can deploy this in your own, sort of DIY Docker solution. You can deploy it in your own DIY Kubernetes solution, because some of the cloud solutions also are Kubernetes or Docker. So you've got a lot of options. Terraform also supports even vSphere. Like there's a vSphere plugin. If you have your own VMware infrastructure and you want to deploy vSphere, and then on top of that also deploy a whole bunch of virtual machines, you can do that. There's another company called Equinix, and Equinix has something called Tinkerbell that'll actually provision bare metal servers. So like, remember the tie-in transport that we have, the 4-node thing? I could plug that into the network and go in my orchestration server, which is based on Tinkerbell. And, well, it's not just Tinkerbell, it's some other things. But I can feed it the MAC addresses that correspond to the Ethernet cards in that server. And then when that server tries to boot and it doesn't have an operating system, out of the box, it's going to try to boot from the network. And the network boot server is going to say, hey, I know those MAC addresses. And if I've sort of pre-told it in Tinkerbell that I want to provision those, I can provision those for Kubernetes or VMware or Windows Server or pretty much anything. We've got some videos coming up on some stuff from Red Hat, OpenShift, and so you can do the same kinds of things like this with OpenShift as anything else. But here is where the snake starts to eat its own tail. Here is where we can sort of talk about this from a cost perspective. Amazon's value, the reason that people are giving them so much money and the reason that the profit margins are so crazy is because if you learn to use that API, you can save a lot of time in your deploy. You can manage your infrastructure, you can manage your infrastructure as code. And for right now today, the best tools are native to the platform. So like Terraform doesn't have every single thing that's available on Amazon mapped into their sort of generic way of dealing with it. You can still access it. Like you can build stuff with Terraform that says, okay, for our specific use case, we're going to need to do something special on Amazon. So Terraform, you do your thing, and then at the end of that, run this script, which will fix up whatever we need in the Amazon cloud. But if you wanted to move that over to, say, Microsoft Azure, then you would have to, provide an equivalent or use the equivalent functionality that's available on Azure. And we have to talk about that in kind of abstract ways because depending on what solution that you're trying to solve, there's different tools. And it's different for every different cloud, and it's hard to give you a specific concrete example. But I will tell you that a lot of the tutorials around, like Terraform and some of the other automation don't really talk about permanent storage. It's like, okay, we created a bunch of containers. We got a hello world container. We got our ingress container from the internet, and we can do load balancing. But it's like, well, I need storage. I need to copy files in and out of storage through something like Terraform as opposed to the AWS CLI. AWS CLI makes it super easy to move things in and out of S3 buckets. It makes it super easy to move things here, there, and yonder. The magic with Terraform is that if I want to change this, and I need another PHP server, because we got a lot of traffic, and it also needs to access that shared storage. So if I upload an image here, and that goes to my storage, then this front end can also get at that image that's on shared storage. This is a really basic thing to be able to do. You'd be surprised how often people get that wrong. With Amazon, even though everything is command line based, they don't really give you any good tools to migrate from the previous configuration to this configuration. You sort of have to do that yourself. With Terraform, it's built into the tool. Handling the migration from this to this, or let's say that things are less popular and things die down, and it's like, okay, we don't need to pay for that front end anymore. We can just sort of do away with this. Then Terraform will take you from that configuration to this other one. Amazon does have some tools for handling this built in, but they approach it a different way. It's things like their, automatic scaling load balancer and things like that, where they can just handle it internally. There's also, another approach called serverless, where you could maybe run the code serverless and it would just sort of scale as it needs to. That does actually make a lot of sense for some other things, but let's stay on topic for how the snake is going to eat its own tail. So again, back to our basic example here. Storage, for my images or whatever, let's say that's S3 and not the Elastic file system, just because it makes it a little simple. And let's say that I upload 1 gigabyte of images. Well, that's going to cost me about 2.5 cents for monthly storage on Amazon, give or take, I think, if I've done my math correctly. So 2.5 cents to store that gigabyte. For me to transmit that to the internet, it's a little less than 10 cents. Let's just round up and say 10 cents. 10 cents for me to send that gigabyte to the internet on the Amazon S3 side. Now, that's just what my options are. I might be able to use another Amazon service to be able to do that. But could I set up my, PHP instance instead of uploading it to S3? Could I upload it to Linode? Could I upload it to Azure? Could I upload it somewhere else? Well, I can log into the EC2 instance and I can configure that, sure. But what I'm looking for is a tool that will just automatically, it's like, okay, you know what, we ran the numbers, and it's actually a lot cheaper to use Linode's object storage than S3. So I just want to go in my Terraform configuration file and change it to use Linode instead. That's the promise of a tool like Terraform. Now, here's where it gets interesting. Remember how I said it's 2.5 cents to store that gigabyte of data, but 10 cents to do egress to the internet? What if I could put something in front of S3. I could put another provider in front of S3 that caches things from S3 and returns it to the internet. I can do this through the magic of DNS. This could be like images.blog. This could be images.blog.dev, which I probably had something like that set up for the S3 side of it anyway. And so as the internet is requesting images, this thing will only request images from the storage, the S3 storage, if and only if it doesn't exist in the S3 storage. So this whole thing continues to work in the Amazon ecosystem. Everything works with the Amazon API. Everything's good. But by using this as a front end for my images.blog.dev, I can very low effort bolt this onto my existing infrastructure. Now, that'll work just fine with or without Terraform. I could have done all of this manually, and it's totally fine. Really, the only thing that I need to do here is make some changes in DNS and make some changes in the storage provider. Well, Cloudflare is doing this, and they call this R2. Now, the crazy thing about Cloudflare is they cache pretty much everything. They're a huge provider, like DDoS mitigation, caching, geographically distributed stuff, whatever. So they actually only charge you storage fees for the thing that you're caching. They don't actually charge you for the traffic. I'm not sure what the business model is here, but with the R2 product, they don't actually charge you for the traffic. They just charge you for storage. And that kind of makes sense because Cloudflare doesn't charge you for traffic on the caching side. Like if you sign up for the $200 a month plan and you put Cloudflare in front of your website, it's just going to sit there and cache and mitigate denial of service attacks, and you don't pay based on usage. This is kind of the same thing, except it's just object storage. So with R2, I'm going to pay a few cents per month, something on the order of like 10 cents. So what am I going to pay in R2 storage? Is it going to be like $1 or $2? No, it's actually less than S3. It's like 1.9 cents, 2 cents, something like that per gigabyte. So Cloudflare, super aggressive, mind's blown. So if somebody downloads something from the internet, like if I have 1,000 visitors that download this gigabyte, I'm only going to pay one transfer from S3 to R2. Now, if I've got multiple regions set up, I'm going to pay per region, but it's going to be vanishingly small. 1,000 people downloading that gigabyte directly from Amazon is orders of magnitude more expensive than this. And I know what you're thinking. Nobody ever got fired for using Amazon Web Services. Well, technically this still does use Amazon Web Services. If you are using something like Terraform, you can close the loop. You can have a monitoring system over here that's continually probing things and looking to see that your blog is up and that the images have good access time and blah, blah, blah. And you have an A and a B configuration for your blog. And so if this monitoring thing says, our A configuration, which includes the Cloudflare R2 caching thing, is starting to act weird with the images, flip it over to B, and then bypass the R2. That just turns into a DNS or proxy update, or maybe even just a tick in Cloudflare, because Cloudflare through their API will let you turn that off. Depending on what kind of a failure they're experiencing, the traffic could still be routed through there, but not actually cached. So depending on what your preferences are, you can have an A config and a B config. And Terraform will take care of managing the configuration state change from A to B in a controlled way. The net effect for you, the customer, is that you save, thousands, potentially tens of thousands of dollars, because the billing structure between the different cloud providers is different. Amazon did not become a $1 trillion company by offering you the best deal possible. But because of the software side of things, makes it easy to find providers. Now, we're not there today, but the next logical step for this is for me to take this manifest, my software-defined infrastructure, which might be a lot more complicated than this, and say, I need this for storage, I need this for ingress, I need this for DNS, whatever. I define that in some kind of a file, and I put that on the market. And then all these different cloud providers will actually bid on my solution in order to be able to host it. Sometimes you hear multi-cloud, like maybe we want to be able to deploy this solution to both Azure and Amazon at the same time in order to have redundancy. Yes, I know Amazon has multiple availability zones, so does Azure, so does the Google Compute Project, but maybe we just don't trust them. It might be like Facebook. Facebook deleted itself from the internet the other day. Could something like that happen at Microsoft? Could something like that happen at Google? Probably not. They probably know what they're doing a little bit better. But you never know. And if you could just hit a button and migrate your solution with all of the data from the last backup or the last instance or the last time it was reachable to another cloud service provider, certainly your IT people would sleep better at night. And that's the promise of infrastructure as code. And we're almost there. Like, this is going to happen overnight once all the software pieces are in place, once all the API interfaces are in place. It doesn't matter that Amazon and Azure and Google Compute all have different APIs for doing this, because there will be tools like Terraform in order to be able to do this. Now, I kind of danced around it, but another thing that you should keep in the back of your mind is edge compute. So, like, you have your company that's got its fancy pants internet connection, and you want to host something internally. You almost get mocked. You go to the IT meetings and stuff, the regional company meetings. It's like, hey, we're going to host something internally. They're probably making fun of you behind your back because it doesn't make any sense. But it's a pendulum. In the beginning there were mainframes, and then there were mini computers, and then desktop computers, and then everything was on the internet, and then everything was in the cloud, and now things are kind of in the cloud, kind of not in the cloud. And then we have serverless because nobody wants to provision a server. It's a trend toward less effort for more results, really, is what we're talking about. So what if I told you that you could run internal infrastructure for your developers and for testing that uses the same API and software interface as everything else? See, Amazon already knows the writing's on the wall with this. They offer their big customers custom availability zones. Microsoft just rolled that out about 6 months ago in Azure. So you can create your own availability zone that's on your own hardware and your own infrastructure and still be able to use the Microsoft API or the Amazon AWS API internally. This is really awesome for testing, deployment, making sure everything is going to actually work correctly before spending a bunch of money to roll it out to production, or rolling out to production, finding some critical mistake, and then rolling it back. And so that's what we kind of mean when we say, edge compute. This is sort of at the edge of your infrastructure. It's at the edge of the internet. But historically, how those systems are managed is way different than how all these are managed. But with tools like Terraform, you can totally do that. And to be sure, Terraform doesn't actually do that, but HashiCorp has other tools like Vagrant that do actually do that. And you combine something like Vagrant for virtual machine configuration or bare metal configuration with something like Tinkerbell, which does the bare metal initial provisioning, the initial operating system installation. You can string together several of these different tools and end up with a really incredible result. I'll also mention Ansible. Ansible is another tool that is really great for managing configuration across a whole bunch of virtual machines. Say you set up a Minecraft server and you don't ever want to do that again, and you want to capture all of that knowledge that you did it. Instead of writing a how-to, you actually just write the playbook for how that works and add comments in there. And the infrastructure is code. The how-to is code. Nobody wants to copy-paste the commands into the command line. This is the next level of automation. Because all the cloud providers are facing automation with this stuff, eventually it has to devolve into just a marketplace. And that's going to really seriously erode their margins, I think, unless we end up with an oligopoly of cloud service providers that all agree not to price gigabytes of storage below 2 cents per gigabyte, or not to price, ingress or egress of traffic below a certain amount. Until then, you can basically pit different cloud providers against one another in terms of how they bill in order to dramatically lower your billing costs. If you want to read some fun adventures about somebody else who's been doing this for years, you should check out Troy Hunt's blog. Now, over the years, Troy Hunt has done a number of blog posts, and I love all of these. I read them with fascination. Doing big things for small dollars is a standout, but there's at least 4 or 5 other blog posts. So he combines Cloudflare caching with Azure functions in order to be able to offer the Have I Been Pwned database, which if you follow this channel for a while, you've probably used that. You've probably heard us talk about that. You can put in your email address, and it'll tell you if your email address has been compromised. You can give it your password, and it'll tell you if your password's been compromised. And it's like, wait a minute, that sounds like a honey trap, giving it my password. It doesn't even transmit the password over the wire. It actually hashes your password with JavaScript in the browser, and it doesn't even transmit the whole hash. It just transmits part of the hash, and then the server will send you the block that contains that hash, and then the password is checked locally. So all of the stuff happens locally. There's not really an opportunity to steal your password in that workflow because your password never actually leaves your browser, which is pretty brilliant for the way that it's architected. But I digress. He's able to host this thing, which has, millions and billions of queries, and is now actually, I think Microsoft, the last news that I heard on this is Microsoft has actually integrated the database into Azure Active Directory. So you can hit a checkbox and this database that he maintains of known stolen passwords, or like your stuff has been so when you try to set your password in any Azure Active Directory, it'll say, whoa there, that password is a known weak password that showed up on the bad list. I don't think that's on by default, but you Azure Active Directory administrators out there, it's one click to turn that on and you really should do that because it's amazing. But it's been a one-man band forever, and so hosting costs is a big deal. And I think in the one blog post he's like, where it is right now, it's like $20 or $25 a month. That's incredible. That's absolutely bananas, because if you were to host that entirely in Amazon, it's going to be like $60,000 a month. So if you work in this industry, it's worth your time to dive into some of the stuff that I've talked about here and learn it a little bit, because you might be surprised. And like if your CIO is like, I'm just not comfortable with anything that's not Amazon. Well, technically this is still Amazon, and technically if something goes horribly wrong with R2, your data still exists in S3, and the internet clients can still pull that data from S3. So you've not really left S3, you just have a little bit of extra caching for just the images, or just whatever your S3 object storage is, in the specific case of R2. Now there are other cloud providers out there that offer similar deals, but the Cloudflare deal right now is insanely bananas, to the point that it's probably market disruptive. But you can do this kind of thing like Troy Hunt has been doing, and like I'm talking about, and save a bunch of money with your hybrid multi-cloud solution, whatever. And then you can say you're multi-cloud, and maybe that ticks a box for the CEO who doesn't really understand things. I don't know. Yeah, so this is really exciting because we're on the precipice of like a flashpoint of a change maybe in cloud service providers, where system administration is easier at the edge, and system administration for cloud management is a little easier in the cloud, and we've got better tools for monitoring and availability, to the point that they can take action if the US East region goes down, or if Microsoft has another DNS failure or something like that. Your tools can just handle it all themselves and basically be good to go. It's the next level of automation, and eventually we're just going to have an API marketplace where everybody's bidding on, okay, I think we can host that blog for like $3 a month. And then, it turns out that something else is cheaper, and you just hit a button and it migrates somewhere else. I'm Wendell, this is Level 1. Let me know what I got right and wrong, or what your setup is, or share your stories, because some of you have some really good stories at Level 1. Be sure to stay tuned for our upcoming content. We've actually got a really amazing OpenShift cluster on a single box. We're testing both Epic and the Xeon 8380, and the results might surprise you a little bit, because oh boy, those 8380s have lots of I/O bandwidth. It's really interesting. So stay tuned for that. We're running a Ceph cluster on a box with like 64 kilobyte. We created virtual network interfaces that have 64 kilobyte frames, which turns out to be a pretty cool Ceph hack. So yeah, I don't know. Stay tuned for that. Get subscribed, whatever. I'm Wendell. This is Level 1. I'm signing out, and you can find me in the Level 1 forums. Share your stories there. All right. I'll see you.